Hi, this is Victor Morganti from FactEngine. Today we'll be looking at natural language queries over a relational database and where those natural language queries are graph queries. We're looking at the Boston conceptual modeling software in front of us with a model that's open. It's the cinema bookings model with a set of pages, and the cinema bookings model is derived from that originally supplied by the Active Fact projects on GitHub. Now, I've got some pages open. This page is a property graph schema of the model, and the cinema bookings model is for where seats can have bookings for sessions to watch films at a cinema, and where a booking is for a person, and where a person can like a film with a rating, and seats are in sections, in rows in that cinema. So Boston allows you to view your model as a property graph schema or a entity relationship diagram. That's the entity relationship diagram for the database, and it also allows you to view your conceptual model as a object role model. Now, object role modeling is the most semantically verbose conceptual modeling language in the world, and uses predicates to define fact types, to define relations inside the model. So we can say person likes film as a fact type, where person plays a role of liker and film plays the role of liked film. You don't have to have names for roles in fact types in object role modeling, but sometimes it helps, especially for databases like TypeDB, and where that relation has a rating. So person likes film with a rating, and even attributes on your tables are expressed as relations, where film has name. So the name of a film is established as a relation. So predicates are used right throughout object role modeling, and the predicates is what ultimately allows us to write natural language queries over our database. So if I right click on the model and go to FactEngine, FactEngine is a productivity tool to write natural language queries over your database, and we can write a query now just to show you how it's done. So let's say we wanted to watch the film Rocky at a particular cinema at a particular date and time. So let's ask which seat has no, so we're introducing negation, booking. Well, first of all, we want to know that our seat is in a cinema. So we want to say which seat is in cinema Great Western Cinema and has no booking that is for a session to watch the film Rocky that is showing on date time the 1st of the 5th 2021, 10 AM, because I know I can watch Rocky at that time at that cinema. And there's our query. So we'll just hit F5 on that, and it's come back with 3 rows. So seat 1B, seat 1C, and seat 20A in the Great Western Cinema. So it's as easy as that to write a natural language query against your database. It's naturally a graph query because it's using ultimately the graph relations inside our schema to formulate the query. So let's write another query now, and let's say Peter turned up and he wanted to check whether he had a booking to watch the film Rocky. So let's say does person Peter, so people are stored as their first name as a login name in this particular database. Have a booking that is for a session to watch the film Rocky, that is showing on date time 1st of the 5th 2021 at 10 AM at the cinema, Great Western Cinema. So it's come back with a row which confirms that Peter does have a booking to watch the film Rocky at the Great Western Cinema on the 1st of the 5th 2021 at 10 AM. There's a red line under have because we don't have a relation that says person has a booking. We've got a relation that says person made a booking, but FactEngine uses heuristics to work out that it can only possibly be this relation because it's the only relation. In some circumstances it'll check, if it needs to check, that you've got the right predicate between your various entity types, entities or nodes in the model. Now what we used in that query was reification of session, where film is showing on date time at cinema. So a session is where film is showing on date time at cinema. So in our query we said, does Peter have a booking that is for a session to watch film Rocky, and then we explain the selection criteria for that reified relation that is showing on date time at cinema. So film that is showing on date time at cinema is session, so we can ask, does Peter have a booking that is for a session to watch the film Rocky that is showing on date time at cinema. So that's a brief introduction to FactEngine. I would argue that it's some of the best natural language querying over databases anywhere, and the thing about FactEngine is that it doesn't rely on machine learning. So if you get a result back from FactEngine, the results are 100% guaranteed to have a correlation with the database and a query over that database. So that's the SQL query for that database. For TypeDB it produces TypeQL, and FactEngine at this stage doesn't operate over any graph databases because you get a lot more utility from a relational database that allows you to express not only that you have a node session, but that you also have the internal predicate film is showing on date time at cinema, and so you have a lot more flexibility over the way you write queries, graph queries over a relational database. We also can use another aspect of object role modeling where there's an implied relationship between a session and a film, and where we can say a film, sorry, is shown in a session. So let's take another query and say which film. Well, let's go even one better and say film Rocky is shown in which session. So Rocky is showing on the 1st of the 5th 2021 at 10 AM in Cinema 1. So that's using what's known as a link fact type between a session and film that allows us to use the reified session to link directly to a film, and ultimately that's what gives us our property graph schema view of the model as well. So thank you very much for watching. I hope you enjoyed the video. If you enjoyed the video, please hit like and subscribe, and I'll see you in the next one.